Welcome to day 17 of our challenge. Yesterday we have implemented Entity Framework, well the DB context, and today we will be taking a look at concurrency. Imagine a flight with only one remaining seat, and Alice wants to book exactly that seat. So she sends her request to the server, and the controller then fetches the flight Alice wants to book from the database. Entity Framework creates an instance of the flight entity in memory and loads the flight Alice wants to book into. The flight entity then checks to see if it has the capacity for Alice. And if the flight has the capacity, the flight entity instance books the flight. The flight entity instance books the flight and updates its remaining number of seats field in memory. Notice that the number of seats is only updated in memory but not in the database. So we need to save it and update the number of remaining seats field in the database to prevent other users from overbooking the flight. Alice booked the flight as expected without any issues. Now imagine a scenario in which there's also another user named Bob who wants to book the same flight at the same time while there is only one single seat remaining. In other words, Alice and Bob are going to compete for the same seat on the same flight. This situation is called race condition and falls into the category of concurrency subject in the context of computer science. They both send book flight requests to the server simultaneously. ASP.NET creates a new instance of the flight controller for each of them. Alice controller instance and Bob's controller instance both fetch the flight from the database now. Still, Entity Framework creates a different instance of the flight entity for each request in their controller instance. Then, each instance of the flight entity class checks for overbooking. The remaining number of seats field is equals 1 for both instances. So none of them detected any overbooking. Both flight entities then book the flight and update their number of seats field in memory again. Since the entity instances are not shared between Alice and Bob, the single remaining seat is booked for both now. So both controller instances eventually save their changes successfully and the number of remaining seats field is set to 0 in the database. So congratulations, the flight is now overbooked. Alice and Bob have to both sit on the same seat. Entity Framework provides a feature which can help to avoid race conditions in some situations. So as a matter of fact, one of the saved changes comments always delivers to the database first. And if the database could reject the second one, the problem would be solved. Well, but how can we implement that? How to configure the database to reject the second one? As I said, Entity Framework provides such a feature. It's one of the providers to implement the functionality though, and SQL Server Providers does exactly this. So let's do it in action now.